So first of all, we are starting the basic principles of agronomy in this lecture. So agronomy word has been derived from two Greek words. One is agros, that means field, and other one is nomos, that means management. So these are Greek words, and agronomy is the main or primary branch of agriculture. So definition of agronomy. So it can be defined as the branch of agriculture which deals with the scientific crop production, soil and water management. The central theme is that how we can get a good relationship between soil, water and crop. So we need to know the basic things, basic management practices to get a good yield. So the father of modern agronomy is Peter D. Crescenzi. It could be an important question for you guys. And we have the basic principles of agronomy. In this part, the agronomic principles are very important and we have to know, because that will help us to get a better management of soil, plant and environment. After that, we can get a economically maximum benefit or return in a particular area or in a per unit area. Mainly in a 1 hectare land, we are getting 1 lakh rupees. So if we can give good management of soil, plant and environment, then maybe we can get around 1.2 lakh per year. So that could be very helpful us. So we need to know that thing. After that, we have the subject called agrometeorology. In this agrometeorology, we just study the climatic factors in relationship with the agriculture. The factors are rainfall, solar radiation, temperature, air pressure, humidity, wind. All these things are related, and we have to know how they are related with agriculture. So in low rainfall areas, the crop failure may occur, so that look like this. And in high rainfall areas, there could be effect of ponding. And if we see that maize plants or corn plants having 6 hours of ponding effect, then their yield may get decrease up to 50%. After that, if we get optimum rainfall, then that will be best for their growth and for their yield. That then in high temperature areas, we mainly cultivate the cotton, because it is also a very important agronomic crop. Then we have in low temperature, we cultivate the barley. Then we have to know what is soil and what is tillage. Mainly soil, it is a medium, or you can say it is a natural body that is present on the earth surface, having some layers of minerals, and that is mainly variable in thickness. Somewhere the nitrogen percentage is more, somewhere phosphorus percentage is more, somewhere organic matter is more. So that could differ, and also depending upon their parent material, mainly how they are formed, we can get different properties like morphological properties, physical properties, chemical properties, mineralogical properties, biological properties. All that properties or characteristics will be different according to the parent material. Then we have the tillage. Tillage, it is just an agriculture preparation of the land. Mainly we prepare the soil by plowing it, splitting it, or turning around all that stuffs. And this tillage is classified into 3 division, that are primary tillage, secondary tillage and intertillage. So physical properties of soil, if you see, then depending upon the texture, the soil is classified in 3 parts, that are sand, silt and clay. Sand, they have the particle size of 0.05 millimeter to 2 millimeter. Mainly their size are big, and they have more pore space than any other soil particles. So the water holding capacity is very low, but drainage is very effective in this sand. But silt, it is the particle size of it is around 0.002 millimeter to 0.05 millimeter, that is medium, so the water holding capacity will be like medium. And in clay, the water holding capacity is very high because the particle size is very less, and the pore structures are mainly very small. Mainly micropores are more in clay, but as in sand, the macropores are more. What we'll know what is macro and micropore later. So depending upon the soil structure, there are mainly 6 classification. One is granular, that has high permeability for water and air. Then we have aggregated. Then we have blocky, that has moderate permeability. Also columnar or prismatic has moderate permeability. Then we have plateau-like, that has low permeability. And massive type of structure of soil, mainly they just look like rocks, they has very less permeability. Then we have the physical properties of soil, mainly depending upon the porosity. Mainly it could be porous, it could be non-porous, and also depending upon the permeability, we have non-permeable and permeable. So this is non-porous, mainly you cannot see a good amount of pores. This could be a pore, this could be a pore, but these are very less, so they are non-porous, and no water or air could pass through that area, so this is non-permeable. But in porous region, you can see this has good pores, but they are also non-permeable because the water cannot pass through that area. But in porous and both permeable, they have bigger gaps, and in that area the air could be present, the water could be present there. So the porosity and permeability both are good here. So the pore space, mainly they are there are two types. One is macropore, another one is micropore. So macropore, they have bigger space, like this block, these are bigger pores. So in that area the air could be present in good amount, and water that is surrounded by that is surrounded over the soil particle. Mainly these are soil particles, the gray color, and the blue color is water, and these gaps, in these gaps the air are present. So you can see this is non-compacted, but in compacted they are very close and the air space is very less. Water is present there, soil particles is also present, but the space in are very small. So this type of space or pore is called as micropore. Then we have plowing. It is the general thing for doing tillage. Mainly we do primary tillage by using the country plow. We can also use the tractor and moldboard plow to have a good tillage on the land. And then we have soil and water conservation. So soil and water conservation is very important because we need to know how we can manage the soil from erosion. If we don't do any prevention, then that will cause into reduced fertility, because there could be overuse, acidification, salinization, and also other chemical contamination. And if that happens, then the loss of the topmost layer, mainly the topsoil, will occur, and then we cannot grow any crops on that area. Also, water conservation is very important because water is very much needed to the crops. So we have to stop the wastage of water. Mainly we have to reduce the use of water. We have to recycle the wastewater for different purposes, like we can use it for cleaning, manufacturing, and other agriculture practices. We have to conserve both things, that soil and water, because they are limited and they are natural things that are present on earth. Then we have erosion. If rainfall occurs on the upper region of any land, then the detachment of the soil particles will occur and the water will go down, and they will carry the soil particles with them. So the transportation will occur, and after that the deposition of the soil particles will occur on the lower region. So this is mainly the erosion thing happening here. So the soil erosion looks like in real life like this. Then we have gully erosion. This is also a type of erosion. Here the detachment area is very big, and the water that carried out all the particles are also more. Then we if we have to conserve the soil, then we can create this type of bench terracing or bunds to protect our soil from getting eroded. Then we have bench terracing, just like the university's seating arrangement. We have this, there are types of bench, and in that areas we can prevent the soil from getting eroded. So mainly in this region there is a bund, in this region there is a bund, so the water will flow down from one layer to one layer, like step by step. So no soil will be erodes down or transported into the lower region. So all that area will have good amount of top soil. Then we have strip cropping. Mainly in strip cropping, we have different strips that are present, and in these strips we cultivate mainly the crops. Then we have dry land agriculture. Dry land agriculture is an agriculture technique where we cultivate the land which receives very little rainfall. Mainly we use drought tolerant crops like sorghum, palm millet, pigeon pea and mustard. Then dry farming, the farming without any irrigation. In areas, mainly the arid regions, the moisture supplies become an most problematic thing. So that chief limitation is there. So crop failures are more frequent. But in dry land farming, the areas are semi-arid regions. Their moisture supply is also a chief limitation, but here the crop failures are less frequent. Then you have rainfed farming. In these areas, the mainly humid regions are there. So without any irrigation, we can get good amount of rainfall. So moisture supply is not a limiting factor, but because we are getting good amount or very good amount of water from the rainfall, then drainage will be a problem. If you don't have good drainage facilities, then crop failures may occur. But still, crop failures are rare. So types of dryland farming, if dryland agriculture, mainly dry farming, has less than 750 millimeter of rainfall per year. If it is more than 750 millimeter of rainfall per year, then it is known as dryland farming. And in rain-fed farming, more than 1150 millimeter of rainfall per year. This is the picture of dry farming. You can see there is no irrigation facilities are there. And in dryland farming, we mostly depended upon the rainfall, and in that area we don't give any irrigation also. But in rain-fed areas we give proper irrigation, and also we don't need irrigation mainly. Here the rainfall can provide good amount of water that is needed for the crops. So in that area the water supply is sufficient, so we can cultivate the rice there. And we have mineral nutrition of plants, and then manures and fertilizers. Plant nutrition is very important because in this part we can study the chemical elements, mainly the nutrients that are needed for plant growth. So that can be provided from manures or fertilizers. Manures, they are organic, mainly they are produced from the animal or plant origin, and they supply all the primary nutrients including micronutrient, and they are mainly well decomposed natural product. But fertilizers, they are inorganic, they are created artificially by industries, and they can provide specific type of nutrients. So in the plant nutrition study, we can see there are different type of nutrients classification: basic, macro and micro. Basic are carbohydrate, carbon, hydrogen and oxygen. These are present in air and water, and they are very important because they create the primary structure of the body of the plants. And then we have macro and micro. In macro nutrients, we have primary nutrient and secondary nutrient. Primary nutrient are NPK, nitrogen, phosphorus and potassium, and we have secondary nutrients: calcium, magnesium, sulfur. In micronutrients, we have iron, manganese, zinc, copper, boron, molybdenum, chlorine, nickel, and all these things are present in soil. Then there are different forms of nutrients taken up by the plants. This is one chart and this is another chart, don't get confused. So nitrogen, that can be present in ammonium form or nitrate form. Then we have phosphorus, that is present in H2PO4 minus and HPO4 2 minus form. Potassium is present in K plus ion. So you have to know all that stuff. Just remember these things. After that, we have manures. They are mainly organic in nature, and this is the farmyard manure. We collect the farmyard leftovers, mainly the feed leftovers, the urine, cow dung. All these things are kept on one area, and then we just transport that things to the land or farming area and used as manure. We just transport that thing almost 1 month before we plant our main crops. Then we can have compost. Mainly we use the leftovers of the vegetables, and after some days they become a good manure like thing. So we can also use that things on gardening or other plant thing areas. So we have fertilizers. They are mainly inorganic in nature, and they also provide proper nutrient that are needed for plants. So there is nitrogenous fertilizer, potassic fertilizer, phosphorus fertilizers. So nitrogenous fertilizer are urea, ammonium sulfate, calcium ammonium nitrate, ammonium nitrate. Urea is most important because it contains 46% nitrogen. Mainly 46% nitrogen means 100 kg of urea will provide 46 kg of nitrogen. That is minimum. Okay, and that urea is look like white crystalline. And after that we have phosphatic fertilizers. They just provide for phosphorus. So SSP is one important fertilizer, and then we have double superphosphate, triple superphosphate, rock phosphate. So single superphosphate provides 16% P2O5, 12% sulfur, and 21% calcium. This is very important, 16% P2O5. And if we see that double superphosphate, that will provide double of this amount, means 32% of P2O5. Triple superphosphate will provide almost 48% of P2O5. Then we have potassic fertilizers. They are mainly used for supplying potassium, that is K, and muriate of potash is very important, MOP. You can get questions like what is MOP, what is the full form of MOP. So muriate of potash, that is mainly the potassic fertilizer. So MOP contains about 60% of K2O, and SOP contains about 50% of K2O and 18% of sulfur. So that is looks like red colored chili product. Then you have diammonium phosphate. Diammonium phosphate can provide two things, that is nitrogen and phosphorus. So this DAP is very important here. Then we have the irrigation and water management. As we knew before that water is very important, then we have to know how we can manage that thing. So water management is the activity of planning, developing, distributing, and optimum use of water resources under defined water policies and regulation. If we need 2000 liters, we will not provide like 3000 liters. So we have different regulations and also policies that we cannot get whole water from the rainfall or from irrigation. So the management of water should have a good plan, and after that we should distribute all that water to the crops that we are cultivating. So mainly irrigation management, it is the artificial exploitation and distribution of water at a project level, aiming at application of water at field level to agricultural crops in dry season or in periods of scarce rainfall to assure or improve crop production. Mainly irrigations that are given by artificial means, that are provided from submersible or by cutting by pump machines and the tubes. We can give water to the plants, but here mainly where scarce of rainfall occurs, we have to assure the improved crop production. So we use in that areas the irrigation. So that is mainly helpful for aiming good project level production. So there are many methods of irrigation. This is check basin method. Mainly in this region, the water supply is given, and these are the basins where crops are planted. And this area, this is like just like a drain, and water just come out in this area, and then it is just bent towards this area, and here water is transported to the basins by these gaps. So this is the check basin method. Then we have method of irrigation border strip. Border strip means here you can see that the intake of water is here, then water is filled up by these areas, then this is the level, and here the slope is there because mainly in tree drawing this look like this shape of triangle. So from upper region you can get the water, and the water will transfer from upper region to lower region. Okay, then you have method of irrigation of sprinkler. Mainly in this sprinkler there is a tube like structure, and in the upper region there is a small gaps that spray the water in all over the area. So you can see this on fields, mainly playgrounds. You can see that type of things. Then we have drip irrigation. In drip irrigation you can have this type of pipes or big drains, but mainly in that area the water is given to the plants in droplets. So the use of water will be less there, and all the plants will get optimum level of water for all day or for several days. So that is very important to save water. So in that area we use drip irrigation. Then we have weed management. We know that we have unwanted plants in the field, so that plants will cause damage to the main crop because they will compete with the main crop, because they're just like other plants. They need nutrients to grow, they need sunlight. So if they can get the things, the natural factors, they will compete with the crops. But we don't want that weed, because we need the main crop for our economic profit. So we have to manage that unwanted plants. So that are known that is known as weed management. So two important weeds are Cyperus rotundus and Echinoclova. This look like just grasses, and there are also other weeds like Argemone mexicana and other things I can remember now. Then we have cropping and farming system. The farming system is divided into three main systems, that is traditional system, semi-commercial system and commercial system. So traditional system, shifting cultivation and related bush fallow cultivation system, and we have nomadic herding. We will see the pictures. And then we have the semi-commercial system. In this part we have cropping system and mixed system. In cropping system we have rice based, root crop based, then grain legume based. And mixed system we have agri-silvi cultural system, silvopastoral systems, agro-silvopastoral systems. In perennial crops we have plantation and agroforestry, and in livestock we have ranching. So shifting cultivation or zoom cultivation, here we just destroy the areas of forest like areas where we can do the cultivation by removing the big trees. So this is also a picture of shifting cultivation. And then we just cultivate our needed crops. Then we have nomadic herding. We all just have the herd of the animals or livestock and we attach them with a rope, and then we just all go together in the fields where we have grasses or the food of the mainly livestock. So that is nomadic herding. And after that we have rice based cropping system. In irrigated condition we can just go for rice or rice cereals, other cereals like wheat and rice. Under integrated farming system we can do rice, then we can do fish, poultry, and rice, fish, duckery. Mainly the ducks are there. And we have under upland condition we have rice, chickpeas, legume crop, and we have lentil and rice pulses. We have rice wheat pulse, rice toria wheat, rice mustard or on seed. It will be linseed, I guess, and rice barley and rice pea. Then we have agro-silviculture. Mainly it is the part of agronomy where we deals with the agroforestry level. Mainly we can cultivate the forest trees there with the agriculture crops. So this is silvopastoral. Mainly there is pastoral land for the livestock. In that area we just leave the mainly the livestock to feed upon their need. After that we have agro-silvopastoral. Mainly all these things are present. We have agronomic crops, we have silvicultural crops, mainly the forestry level trees or crops, and we have the pastoral land for livestock. Then we have plantation crops. Mainly the plantation crops are those type of crops which need proper processing. Otherwise we cannot eat them. This is the main difference between plantation crops and the fruits. Tea you can not just eat without being processed of that thing. So tea is there, coffee is there. You cannot eat directly cocoa. You need cocoa seeds, and after that the cocoa seeds will be transformed into chocolate. And we have also cashew nut. You cannot eat it without any processing. Then we have ranching. Then we have the sustainable agriculture. The sustainable agriculture refers to the ability of a farm to produce crops and maintaining the soil health without causing severe or irreversible damage to the natural ecosystem. Mainly we are just preventing the irreversible damage to the natural ecosystem. We have to have the ability to prevent the different damages. We know that when we are producing crops we are using the soil's nutrients, so we have to maintain that thing, that we have to provide the proper nutrition to the soils. And also we have to manage the soil's microorganisms that are present, because they are also very helpful for creating the sustainable agriculture. So the soil health should be maintained here. Then we have the sustainable agriculture thing. Here we have the soil salinity management. Then we have the energy management. Mainly the solar plates are there. Then we have the nutrient management and soil fertility management, integrated pest management. All these things are done in this area. We have tractors which can have post harvest losses management. We can have a pasture land where we can do the livestock management, pasture land management. Then we can have normal good trees like agroforestry trees to manage the erosion. We can have also the water and irrigation management by providing or getting a river or making a channel. And also we can do fisheries and aquaculture on that area too. And we have also wetland management there. Then we have scope of agronomy. Main things of agronomy are that we have to maximize our yield. We have to get maximum benefit. So we need to introduce new cultivars or high yielding varieties. Mainly HYV is high yielding variety. reduce cost of production due to proper crop management. Mainly the cost of production should be reduced. We are using urea at higher prices because they are only available. That should not be done. We can use a good amount of manures in that price. Also, you can use other fertilizers, like you can use DAP rather than urea, because it provides two main nutrients at same time. So you can use that things, by which you can reduce the cost of production. By proper crop management, we have to use the water properly, and water if you use efficiency is very much needed, because if we don't have any agronomic knowledge, then we will just waste the water easily. So spatial tillage and interculture operations should be done. Mainly weeding should be done, tillage should be done, there should be proper plowings there. And for better crop growth and maximize harvesting index, we should know all the operations that can be provided by agronomy branch. So we can manage the proper fertility which will increase the yields, and with lesser use of the fertilizer for increased profit. Mainly we have to use the fertilizer, but in a proper amount. Mainly fertilizers are costly than manures, so we have to know that thing. Also reduced post harvest losses due to agronomic knowledge and practices, we have to reduce that thing. Mainly there are many crops which are susceptible to many diseases or insects if they are not properly stored. Also we have intensive cropping patterns and integrated farming systems. You will know these things, how we can do a good proper cropping pattern, rice cereals, or rice legume pulses. That things are also there. So proper cropping patterns should be followed. And also integrated farming system, like we are doing dairy, we are doing cattle rearing, fisheries, agronomy, soil management, all these things together, then it will be called as integrated farming system, for creating a sustainable agriculture that will increase our food production. So now we will discuss the role of agronomist. If you ask any agronomist what is their aim or role, they will just say that they should have the basic and applied knowledge of the agronomy that is related with the agriculture, so that with that knowledge they can help the farmer to get maximum benefits at minimum cost. So for that they can have the different scientific research knowledge that will account into different factors like soil, plant and environmental relationship. So in the broad perspective, the agronomist will help to meet the needs of the growing population. By that they could create a good coordination and discipline among all the subjects, and that will help to grow our own Indian agriculture. After that, we have water use efficiency, that is divided into two parts. That is crop water use efficiency, and another one is farm water use efficiency. So crop water use efficiency is grain yield of the crop by evapotranspiration of the plant. Means evaporation plus transpiration. Grain yield, that will be calculated in kg, and evapotranspiration will be calculated in volume basis. And for farm water use efficiency, that will be also is grain yield divided upon the water requirement. And water requirement, like maybe 2000 liters or 3000 liters in our hectare land, and grain yield will be in quintal or maybe in ton, that could be converted into kg. So unit is kg divided by hectare centimeter. So hectare centimeter is usually a volume unit. If we convert the hectare into meter square, then it will be 10,000 meter square, and you can change the centimeter into meter, so that will be a whole as a meter cube, and that can be converted into deci-centimeter cube, mainly the liter thing. So you can just convert the whole thing into quintal per liter or kg per liter as per your requirement. So that is water use efficiency. After that, we have harvest index. So harvest index, that is economic yield divided upon biological yield into 100. So what is economic yield? Economic yield is the grain or seed yield. Maybe it could be pod, it could be oil seeds, all that things that can give us a remunerative. So that will be considered as economic yield. Biological yield is the grain yield or seed yield plus the straw, stalk or stover yield. So actually the whole yield that we are getting from a plant, that is biological yield. So harvest index is economic yield by biological yield into 100. So for rice, it could be 50%. Mainly the high yielding variety of rice can give harvest index of 50%. And after that, we have pulses that could give around 25 to 30% harvest index. And lastly, the fodder. Fodder can give 100% harvest index, because the economic yield equals to biological yield. Means all the vegetative part, that is stalk, stover, all the things that are present in the fodder can be used as economic thing. So the harvest index becomes 100 by 100 into 100. So that will be just 100%. After that, we have different type of regulation. Green regulation, that is for food grain. Then white regulation, that is milk. Yellow regulation, oil seed. Blue regulation, fish. Golden regulation, food production, fruit mainly. And gray regulation, that is for fertilizer. Pink regulation, that is for prawn. Red for tomato or meat. Round regulation for potato. Silver regulation for the egg or poultry. Rainbow regulation for all the brown stuffs in the production, mainly food grains, edible oils, fruits, vegetables, animal, fish production. All the things can be considered as different colors, so that will be look like a rainbow. So that regulation is called as rainbow regulation. Then we have energy regulation, that is for mainly food, nutrition and environmental security for our future generation.